I want to take a brief detour here and discuss dividing by zero. And I like to do that. I like to make a big deal of this because it's an issue which is going to crop up from time to time. And in particular, in this section it does. And so, how would you handle this type of question? What is 3 divided by 0 equal to? All right. Well, usually it would come to you in this form, 3 over 0. So what in the world does that equal to? And if I tell this to a beginning algebra class, someone will say it's 0. Why? Well, because about anything you do with 0 gives you a 0, right? It's more complicated than that, isn't it? Okay. And so by the time I get to college algebra, someone usually says, well, it's undefined. What do you mean it's undefined? What does that mean? And so textbooks typically say, oh, that's undefined. And I don't like that, because what does that mean? So let's talk about that. And why is it undefined? I think that's another thing you should know. And so it's just part of building your understanding of algebra, which is going to be kind of crucial to you doing well in this course. I think it's a good idea to look at this. And again, I make a big deal of this because I want to make an impression on you that you can't do this. All right, so how do you do division anyway? When you first learn division with natural numbers, positive integers, you were tapping into your knowledge of the multiplication table, most likely. So for example, if you had 32 divided by 8, you figured that was 4. And why is that? It's because 8 times 4 is 32. And so we typically learn our divisions as children as an opposite of multiplication, as the inverse of multiplication. 8 times 4 is 32. Great. So if 3 divided by 0 was equal to 0, then that would mean that 0 times 0 would have to equal to 3, wouldn't it? And it doesn't. Obviously it doesn't. And so, in fact, nothing you put there is going to work, because 0 times anything cannot give you a 3. 0 times anything will give you 0. So what should we say about 3 divided by 0? Or anything divided by 0 can't be done. Can't be done. All right. I suppose you could say, well, that's an undefined operation. But usually the books shorten it to the word undefined, which I don't think is a very good description of this. All right. Can't be done. So there's no way you can put a number here that's going to fit because of this multiplication business. So that's a problem with our real number system. We can multiply any two numbers together in real numbers, and we can divide any two numbers provided we're not dividing by 0. So 0 is a big exception to our real number system. It's the only number we can't divide by. Now, as long as we're on this topic, let me throw the other. This one's even stranger. Because what if you had 0 divided by 0? Alright, so 0 divided by 0 is really a strange bird. Because here 0 would work, wouldn't it? Matter of fact, so would minus 13. Well, it would, wouldn't it? Because 0 times negative 13 is still 0. In other words, I can put anything there. And so 0 by 0 is yet another animal here where it looks like any number you put here is going to fit. And so really that can't be done either, because in this case 0 divided by 0 could have any answer you want to give it. And that's no good. And so that also can't be done. We call 0 divided by 0 an indeterminate form. And there are a few of these in math. Indeterminate form. There are some others. Let's see, 1 to the infinity power is an indeterminate form. Infinity over infinity, that's indeterminate. Infinity minus infinity is indeterminate. There's probably another 1 or 2 of those that I'm not thinking of off the top of my head. We study these in in calculus. Actually, about calculus 3, I think, is when we really start to study those seriously. But we do confront this issue in calculus. It is at the basis of differential calculus. And let me just give you a moment to show you where 0 over 0 could come up. All right, if I'm dropping this pen and it falls, I want to ask the question, at what speed is it traveling at this point in time? So as it falls, if I just take a snapshot right here, at this instant in time, how fast is it falling? Sir Isaac Newton attempted to answer questions like this. Or if I drop this pen, how fast is it going when it hits the floor? Well, we measure speed by taking distance and dividing by time. For example, if I walk across this room, suppose I walk 12 feet in 3 seconds. 12 feet divided by 3 seconds gives me 4 feet per second. That's my speed. How fast is a pen falling at this instant in time? Well, at this instant, how far is it falling? It's falling 0 feet. And how long does it take to fall 0 feet? 0 seconds. So ask this strange question, how fast is the pen falling at this instant in time? Is equivalent to attempting to divide 0 by 0. And so that was sort of the issue Sir Isaac Newton and some others ran up against. And Newton and a German, Leibniz, both figured out how to handle that problem. The way they did, they said, well, let's see what happens when we get very close to this. So it wasn't that they were trying to solve 0 divided by 0. For example, 0 feet divided by 0 seconds. You can't make any sense of that. But what they did, they managed to find a way to get real close to that 0 over 0, infinitesimally close. All right, so I hope that made a little bit of sense to you. But if you take calculus, you'll probably see that discussion, and because that's at the heart of differential calculus, is really grappling with this particular crazy division by 0. So, all right, I don't think you're going to run into 0 over 0 in this course, but you will run into other numbers divided by 0, which can't be done. And the main thing, again, I like to make a big splash with this because I want to impress on your mind to be alert to division by 0. Be alert when you see that, and when you see it, you know it can't be done. So, and you will see it in the next video.